Hello, so today I want to play again learn Golang and do the same what I did last time. Try to build something called buffer file or buffer input output streaming. Okay, it's pretty should be simple. We need to let's start coding something. So I will create some new file buffered file go, and the problem what I want to solve the problem I would like the problem I would like to do it's not exactly to solve the problem like to write a file in buffer mode. It does not make sense, but the idea to have something to to write in the middle with efficient memory and then flush, and try to do this in with less memory allocation, so it should be static. It should not spend a lot of resources on allocate new arrays and everything else. Yeah, okay, so how can we build an library to write? It should be anything input output could be, but we pick file, right? Try to stream probably, maybe like let's put file stream or input output, anything. It has interface methods. It has two methods, so its interface has two methods, write and flush. On write we assume we put something just bytes, so what we get in bytes mode we get this and we write the same stuff. We don't care like how it was serialized, who did serialization, convert from types. We expect the simplicity. Side mission, it should be thread safe. And what does it mean? It's when we write in buffer, it shouldn't split messages in the middle. For example, we have some sample. We have two go routine or two concurrent writes. For example, write ABC and write 1 2 3. It should be byte, yeah, so it's like this is abstraction, we don't care much right now. And output should have ABC, for example, and then 1 2 3 4 or 1 2 3 4 ABC. Result output should have ABC. Yeah, so some primitive, right? So we have file new, I don't know, like pass. Then there is our buffered solution, so buffered file, and we should give file stream and the buffer size should like 2048, and then we have interface right, so it should probably byte something, and I think we have this is somewhere like in Golang. How can you convert string to bytes without any extra allocations? So I would pay attention here. Check for converting string to bytes. And the second is bflush. So this is what I want to achieve, to build. We want to have this buffered file. This is semantic language, like I put Ruby and it does not looks Go, so that's what I'm learning here. Okay, so we start with package main, right? Why? Hey, syntax sugar, you're stupid. Why you? That's okay. So we have package main. So we start from import, probably format, and then func main, and we should print something, right? Print line. I start from simple as possible, so I would try to avoid can I do format? Yeah, I can. Okay, and I just want to familiar with tooling stuff, and that's why I start with buffer. Wait. Okay, it's Golang and it's buffered. Ah, okay, I put somewhere in wrong place. Oh shit, don't move. Yeah, okay. So we have tools. First, just playing. We have problem. Go. So first thing, Go doesn't like the best of the best comment style. Egg. So we convert to this one. Probably there is some best practice, so I don't care right now. I mostly care about learning about how to open file, how to write file, and then how to do this buffering. So what we have here, and a legal character tag, yes, because we didn't save, and we see helpful. Great, good achievement. Okay, now let's play with files. In this case, it should be some sort of file input. So I would like to learn where is this Golang by example, probably example file, right? Yeah, okay, not the best. Wow, and we have example, this one. So it gives you some, actually, oh my god, it's already buffer IO. That's amazing. I think this will be just primitive in Golang. It's all tooling it already does. Okay, so what do we have? We have this is byte. Remember, like what we put string, and we have write file, os write file. We check for error, so it's some sort of extract 3 lines with single line. and I would assume this will be inlined, so that will be looks better than we always have if error, checking for error stuff. Okay, so this is handle errors actually. Here create file, write file, we have defer close, so when we create file we need to close in the end. Then what we have here, we have pure bytes, we don't care like it's string or bytes. Can I have like Golang convert string to bytes in efficient way? Right, okay, it has some filters. Cool. Okay, this tutorial, it's not original one, right? Golang tutorial dev, is it not official one? So this is what we usually do. It's byte and string. And yeah, we want write file, so file bytes permission. And now we go to learn this one. So there's a string and we're converting bytes. Cool. How can I make sure that the string actually, so when I do this one, does not create a new, doesn't do copy? No good. Okay, so we want to, let's back to our problem. So this is what I found. Byte to convert string to byte, and this is encoder. No, it's hard. Oh wait, how to convert Golang string to byte array efficiency? So we have string conversion byte array. Yes, understanding string to byte array in Golang. Blah blah blah. So we have strings, they have lengths, byte array in Golang. Yes. And you can modify elements here, and because this is one single character, so it should be converted automatically in ASCII code. And now we want to do this. So is it efficient? Yeah, so the byte is mutable, the string is not mutable. And okay, this is interesting. So let's do it. So I have string help me, and then I have array by bytes. It should be byte string, and what I would expect if I change the first character here, so it should not like help me, and then I do printf string is equal to this. Okay, no new line, and we have it. Help me, yeah, so this means it's actually copy paste, or so we don't have bytes. It's not exactly the same what we expected. Bytes 80 something, right? So okay, cool. So bytes string, it's not efficient. And now with performance consideration, yes, I want it. Each conversion creates a new underlying array, which can lead to increased memory usage. Yeah, exactly. So this is what to optimize necessary conversion, especially in loops. Perform your code. In conclusion, to send the Wire conversion is Golang is vital for active program. By being aware of the basic and Unicode, you can show failure frequent. And so this like how I can write better. Where is it? So I have byte, yes. Modifying byte rates, yes. Length and capacity, yes. No, byte array. Okay, it's opposite. File input output. Okay, this is not good, my man. File operation. Wow. Image network programming. So before I thought like it's just declare a new type, but it's actually not. Yes, I want to do efficient. I wrote it somewhere, but I already forget. Yes, here. So what do we have? This one. To optimize the performance, it implemented buffer pooling, a technique that reuse existing byte arrays instead of creating new ones, reducing garbage collection overhead. Buffer pooling, and then I have string, I have a new buffer, and it will return me something like a new pre-built like 256 bytes array, and then I copy buffer to string. This is what I wanted. Yes. So this one is no, it's actually copy. It doesn't do reusing the same. It doesn't do like it's like it's still safe, right? So why I assume like there is unsafe. Is this Golang unsafe string 2 bytes. I need to remove this one. How to use unsafe to get byte slice from string without memory copy? Yes, this is what we want. Ta-ta-ta-ta-ta. And we have unsafe. Update, yes. And we have string data. What? It's amazing. We have it. String data returns pointer to underlying bytes of string. For empty strings, the return value is unspecified and may be nil. Since Go strings are mutable, the bytes returned the string must not be modified. Must not be modified. Okay, I want to see sources. Where is my source, right? So we don't trust documentation. And sources very what? So where's implementation? What is it? What is it? Did I misunderstanding? String data. So how it was implemented? Hey, Golang developers, where's implementation? Unsafe pointer file point. Oh my god, this is so. It's not readable, right? Pointer. You should have some symbol like in C, C++. Pointer. Reflect value of. Wait a minute. Like we have asterisk and ampersand. It's exactly two commands. And then we have pointer. Okay, cool. So, woohoo, we have it, right? So let's play with it. Back. Where's my code? So what we want to do is we want to be unsafe. Unsafe is our way because we are super developers and we know what we are doing, right? Probably not. So unsafe string data and string. Then we modify EP and then we see something, right? So what we learn, cannot index be variable type byte. Yeah, so it's return symbol So what we need is change value, no? Okay. So we have this is ampersand, and then we need to learn. So this is ampersand take pointer. We want this and change. How? Okay. Variable of type byte, advanced operation index of type byte. It's not array of bytes, it's just first byte. Okay, cool. It just points to the underlying bytes of string. For empty strings to return values and maybe nil. Since Go string are mutable, the byte return string must not be modified. And I want to return the slice. Probably this one, right? So I return, this is pointer. This is pointer. And I return this slice. Okay, so what? How we want? I want to read this. Okay, so what we have here? We have string original one. It should be bytes, and then like string. So we know it's original one. Original. And then we don't need. So we have originals and bytes. So now I get the byte. So it's some sort of pointer. Sorry. And this means I want to do slice. String data byte and then string. Since Go string are mutable, the bytes pass. Okay, I want to have, and this is opposite. So this one is converting opposite. String data and this return byte. And my bytes probably would be something that string data. Okay, wait, I remember I have used it. So Golang and save string data. Yes, so what we're doing is here unsave pointer and no, I want converting bytes to string, converting string to byte, grabbing. Okay, so we have this with this, bytes to string, string to bytes. Unsave. Oh, this is. Woohoo! Do we have string of bytes? No. Yeah, so we're doing this one. And that means we want to do. Yeah, let's just copy paste. Then we have string to bytes, we have string, we have byte, and then we return the pointer, and then we do the size, and then this is the slice, and this should be this. So this should be bytes, and then we want to. So this should still work the same because we didn't modify, but I want to compare the bytes side. Yes, you're right. Yeah, English. So, okay, so new line. Don't forget to put new lines. We have this one. It's the same, right? So now let's bytes 0, and we put p modified. Right? Wow, yes, we did it. Oh my god, yeah. It's not unsafe, right? So slice return. What is slice return? Arbitrary type. So it's return actually pointer, right? And then if I do like this, would it work? So if I put bytes like this, what will I have? Yes, that makes sense. If I just want to get the first address, okay, I got it. So we don't need actually. I will play later. What we need is this most efficient way to convert strings to bytes. That would help us to write strings in pure strings and then expect some stuff. Okay, so now it's time to learn how to write. So we have help me, we want to write file. So I want to write, and then I have message, and then it should be string, and then it's fine. So here we learn how to write files. So we convert bytes, we get bytes, and then I want to write a file. So here we modified, now we don't need it. And then I put, right, actually I just need this one. Right. What we do is we have bytes, and now I want to write this bytes to the file. So I will have it like file. Where is it? Was example? Yeah, back. So we create file. Then we write file, yes. So first we create. Can I check? How can check OS? Okay, OS. And probably it should go here. Yes? Yeah, we have it. And then file, right? And then we have open file for read access. We want file read. This is buffer, and that what I need is actually not to read but to write. No, actually open. Can I open file? And I want open file for write. I don't want to create it. If it exists, I don't want to create. Okay, let's do create. Open here. Open file, read only. No, I don't want to have read only. Read, write, create, trunk. Okay, cool. So let's create. Let's create, and then this is a file. If it exists, I would append. Okay. We want to create file. we want to create, and then I want test data, and then if error not equal nil, then we panic, so we don't care. And then here we want to write, and here I want to do file. So what type of return? File. Okay, cool. File, and then file I can write bytes. Write bytes, yes. So it will write everything what I have in buffer. Interesting. Okay, I wish it has some limitation and finished based on when string is finished. Should be fine. And then we want to close the file. To close. Right? That should be fine. And let's try. Yeah, this is, but I will use later. I don't want to use. Okay. String message, not string. You're right. This is your right here. Do we have file? Test data. Yeah, we did it. So it works, right? So we try to do like with less memory as possible, and it creates some file. So what's next is we want to write file, but in buffered way. So we want to create a decorator called buffered file, and then we will write there. What should we do? How can we create decorator, right? This is interesting. So buffer new write, new writer. Yeah, wait. Let's read what is it, buffer IO. Maybe it's already exists, right? So it's buffered input output. It wraps reader writer object, creating another object with writer that also implements the interface but provides buffering the same help for textual input output. What? You did the same? This is what I need, right? So in other way, I don't need to create anything. It's already there. And now I would write not in here, but I want to create the interface, and it should be B, for example. And how it was, what's the interface? It's buff IO new new writer. Should I use new writer or should I? Yeah, new writer size, this one. So I would say I need explicit one, and then I provide file, and then I provide the buffer 1 kilobyte. 1 kilobyte, and then it should be the same. And my idea, I would have everything the same. What if, and we have flash. Oh my god, this is so, it's amazing. Flash. So here I would say we need writer, right? So writer is like input output writer. So we don't care about file anymore here. We want to have writer. Do we have IO? No. How come? Is it just IO? Is it just IO? Okay. Rake format. data, just in case. Yeah, do not point it to interface. I don't want to point it to interface. I want to have interface, so sorry. Yes, you're right. Cool, nice. It works. It just worked. Oh my god, like, oh my god. It's actually work, right? So what's next? What will be next? Let's try to do like to implement feature concurrency. This is what I needed, and I would like to have, for example, 1, 2, 3. I don't care about the order actually, but I would like to have uniqueness. And I want to do this. And that means when if I run again, it should be nice. So no remote. So now I assume we want to do this in concurrent. Go far up. Actually, it should be like here. Be flash. No. Can I do sleep? Hey, go by example. Give me sleep. Sleep. Time. Timeouts. Yeah, it has all timeouts. Oh, so I don't want to do like this save mechanism that everything is finished. I just want to sleep. Time to sleep. Cool. We have it. So it should be very fast, so probably 1 second is enough. Right, and I want to import time. I want to import time, and what do we have? Oh my god, no, it's too easy. It's too easy, so we want to create more. For I equals 0 and I less than 1000 and I plus, is it plus plus? Should be plus plus. And I want to do here and okay, now I want to return format. And here I would like to do format printf. Right, and then it should give me integer and it should be I. I actually put integer here. And it should be fine. So we expect 1000 lines with help me. Yeah, so just I will count number of lines. Once again, still should be enough, even like for this one. Okay, and we have buffer 1000, 1 kilobyte, so actually it should write how much we have 11 bytes. So we write, no 11, I'm wrong, 12. We write 12 bytes and we have buffer 1000. No, it's too big. Let's put somewhere 10 bytes. Just for fun. Just for fun. Go, run. And then we do test data. Okay. Oh my god. Oh my god. Help me. Let's put this one in this way. Oh. What? Yeah, this is what I meant, right? Oh, we have it. It's amazing, right? So you see, like when we have a buffer, a big buffer, then it can produce crazy things. It wrote something in the middle, so it was 89. Yeah, I think it will be 93 plus 89, and then help me here. Oh, cool. So currently this is not thread safe. And how can we do locking, right? So let's check. Mutex, right? The same. We have mutex, we have log, so we need to create our synchronization. How can we share mutex? Let's go here. Let's go there. Okay, so we probably will need to create own structure. Right? Can I do own structure? Oh, I would like to just decorate this one. It will be should be fine. Okay. Type buffer file struct, and we have here. So what we have is we initialize with our writer. And then let's buffer, and then we want to initialize our mutex. That should be safe. Okay, and interface. So we want we want to do this. Should be amazing. So buffered file, probably this one, right? So this would not go here, and we remove it, and then we put buffer, right, bytes. And then if we go even better, we just avoid to initialize a temporal variable. Still will be put somewhere, but it's fine. And we want to lock, so we want to do this one, locking. We want to do lock. So actually, no, it's fine. Yeah, so we want to do lock, and then we want to unlock. I don't use defer. Defer is a bit slower. Defer is safer. So if there's like integer overflow, everything is crashing, panic, defer will be executed anyway. But if it's this panic, I already don't care about unlocking stuff. It just will be crashed. So this one is a bit faster, and we need constructor. New buffered file, and then right, this should be fine. And then we will have this your writer. So here buffered file, it's not buffered file, it's just any writer. So we want to have size, right? So where's my size? Size integer, and then we return, let me guess, our instance. And okay, b is equal buffered file initialized with buffer that should be this one, and this with size. So we propagate this writer here and buffer, and then we initialize lock. Okay. No, I don't want you. I want to do like. Do I need to initialize lock? It's automatically. Okay. Container counter. Yeah, cool. It should be enough. Okay. So we have a buffer file. We have already implementation of our BUFIO. Even probably I would try to maybe reuse this one. I don't know, I need to learn. And then we want to write with lock, write, unlock. And then this is our initialization, so we return here this one. It returns buffer, then we do like this. And then we write this string, and then we sleep, and then flush. And when we flush, I don't close it, right? So we close here, but actually it should be also be part of buffered interface. It could be closed. So we want to close this one, but okay. This is not the goal of our. Let's begin. Okay. Where is it? Where is it? Comma. Yeah. We need sync. This is not very nice. Okay, 36. We just because we didn't return, so we don't need it. Let's return. Undefined has no field or method unlock. Because I put here incorrect case. And flash undefined for yeah, you're right. You are just damn it right. Okay, I will do private flash, and this just decorate. Yeah, that's what I wanted to do, like copy interface. Buffer flush. And here we want to do this, right? Right. Oh, so yeah, it's not a writer, you're right, because buffer IO is more than just writer, and that means where am I? Buffer package, right? Writer, and I will return buff IO writer. Yes, you're right. And then here it should be fine. Can't use new data value of type write it as buffer data. Oh, okay. Is it better? Oh, cool. Let's use our test, and we have amazing test data. Whoa, oh my god, so it's so beautiful, right? So now we have it more or less correct. That's all, right? Can I do format? Break format. Sorted? Yeah, probably sorted. So all magic of writing buffer to specific okay, let's put 10. Yeah, to implement this buffer solution, we just copy paste from BUFIO writer. Let's go and check actually how it works. We have write and we have bytes, and I want to see the source. Yeah, and that's what want to be how it's written in efficient way, right? Writes the content into buffer, returns the number of bytes written. Oh yeah, so I forget actually we should return number of bytes. So this one, it should return something. Number of bytes written. If n less than p it's the byte, and what's n? It's how many. It also returns the error explaining why the write is short. Okay. So what we understand that when we return n, it's actually a bit more complex because we do flush, right? And only on flush we write, and then this one, if buffered equals 0, large write empty buffer, right? Yeah. Oh, this is nice. So we have 0. If we are already full, right? So what's buffered? Buffered. So what does mean buffered in this case? Okay, well, here. Buffer returns a number of bytes that can be read from the current buffer. So if there is 0 data, we want to write just in that time, right? So let's read again. Right. Okay, let's back. So when there is buffer available and there is no errors in writer, we continue. So while we have p byte is bigger than available, we want to split in chunks. Oh, nice. So this is where loop appeared. While we want to write. So in original not explanation but task, we want to write to file only through buffer. So everything that go to file to like output should be first be part of buffer. And here it's a, oh look, we have 0 buffer stuff. So this one actually happened when the size of bytes is bigger than we have in buffer. So then just copy through this middle buffer doesn't make sense. We just copy everything what we have. And this will be a bit better case. We don't need to split on chunks because it's already big enough. It's a big chunk and we can write it directly to a destination. So they have writer write, and that means it returns how much bytes it was written. So okay. But when I do write p, it comes here and then we say, oh, p right now we slice. Next, how many bytes we wrote and how many left. So if there is no estimation, like if there is write consumes everything from here, it will return the n, it will be the same size as of p. That means p will be 0, empty array. So then it should be less than available. It's go away, so it should be less than available, and then it comes here, no years, we don't have any years, and we copy the last part. So we put the buffer, the size of buffer, we copy from like the end of what we have to the end from p. So available, if you remember, available, it should be like one kilobyte, it could be, and that it should be empty, so we don't have here any problem. And then again we have this in un, and it should be 0, and then 0, it's just increment how much we increased, and then and it should plus, and it would be 0, it was 0, and now it has 0 plus 0. Okay, so what if we have available bigger and it has some buffered size? So if there is some buffering, then we go to this place and we kind of repeat the same as here. We copy until it's finished the buffer amount of p. Okay, cool. So the copy, actually it's a nice function. Golang copy. Golang copy. Appending to anchor tag. Okay, so let's use this source. Copy built-in. Okay, the copy built-in function copy elements from source to destination. It's also will copy bytes from a string to a slice of bytes. Okay, cool. And the source and destination may overlap. Copy returns the number of elements copied, which will be the minimum of len and len. Oh, okay, so... Oh, built-in functions. Okay, interesting. How Golang... Where is the Golang implement built-in functions? Built-in functions. Golang explain built-in function. And sorry again, my filters. Built-in package, built-in package built-in provides documentation for Go pre-declared identifiers. The items the document here not actually in package built-in, but they descriptors here allow Go doc to present documentation for language. Yes, well, I want to read the source. So it's the same, right? And it's just something that doesn't make sense, right? Go functions with example Golang built-in functions. Okay, maybe you can help me understand. Golang built-in functions. Alice here. Where's it? Where's location? Okay, no, back. So I just trust how it was done. And then this Golang optimization. It's not optimized? Wait a minute. Okay, cool. Okay, I will trust you. Go no inline. And then we will play it. So it just take minimum from here and put n here. So maximum it will be of full, and then we do flush. Why we flush? Because we know that p is by default bigger than it was available. That means n should be full up to the end and then flush. And even I would not bother with this stuff. So if p already bigger we know that it always copies the same, and then bn it will be equals maximum. So why do we need this stuff? No idea. Okay, and then here we again added to results. Yeah, so we need to actually, it's important not here but here to remember to collect our return size. And then again p, and here p already not empty because it copied just this portion of n, and then it will have some other one, like I don't know, 500 bytes, and that will be give us, okay, available right now is bigger than len, so we exit from here. It's not enough to flush, and we, yeah, no errors, and then we copy paste to both. So the slices here is a nice trick. It's actually points part of array, so it's just change the pointer from the beginning array to the last part without any modification, and then we copy the last part to our buffer, and remember that it's a small one, and then we copy. So actually write returns the size of p, but then we don't know. So in this scenario, and will like what will happen if our application crashed and it was reported, oh, it was written like 1 kilobyte of data, but actually it was some portion of data was lost in buffer in the middle, so it was not totally written. And then I don't know. And what about flash? Ah, wait. Just return error stuff. And flash just doing this stuff. Amazing, amazing, right? So okay, yeah, I implement a bit different. I put flash in n in write, but then yes, actually write means how much data was processed, and flash, when you do flash, we don't know, and then we can use other write bytes. Okay, cool. What can we do? Yeah, that's all. So we have everything. We kind of built our function on top of buffer.io that implemented the main function. Is this one, right? So actually all 3 key questions is this one. So we okay, it's reuse of built-in standard library BUFIO. That's kinda did everything what we need. How we work with arrays, right? So this is what important. We don't do append. Here you see, like, it's not doing append, it's doing copy paste. Append is adding some new element. It will resize the buffer and add new element. Here it's important, it's copy and copy. So the magic of copy. Then what we learned here, that slice here it's included, right? So but it means n is the length, how many the length of how many data was written. Still, yes, so always I have this misunderstanding, like how the slide started, like it included, not included, this is what, and yeah, so here just tracking how how many bytes was written to buffer and then it flash. Yeah, actually how it was implemented, flash here. So flashing should be, so if error, return error, nothing to flash, return nothing. Then we just execute write, and then we put buffer from 0 to n. It's some sort of give just slice. Why just doing slice? Why it doesn't give just buffer? What is buffer? Buffer byte. And then when I do initialize with size, it's doing buffer writer. It's okay. So if we writer, if len buffer, no, I don't understand. So there is some sort of writer, and we convert writer to we say, okay, this writer should implement this interface, like type. And then if it has buffer, and the size is bigger than it's already had, then we return. So it's already, could be bigger size. If the size we don't know, and then we have here. Okay, so it could be that buffer IO initialized against buffer IO, so this means this one, and if it's okay, then they just reuse the existing buffer IO object, and then there is not, you don't need to create anything, you don't need to allocate a new object. That's nice. And then here yeah, let's create a new array of size and put writer here. And it should be 0 and then getter stuff. Cool. Yeah, that makes sense. That's kind of all.